Hi, Algebra 2. Today we're going to be talking about ellipses, and let's go ahead and take a look at what they are. This YouTuber is drawing what is an ellipse. If you notice, this ellipse has a relationship here where it's a kind of a string that's attached to 2 points. And what he's done here is he's moved these points in closer, and he's going to show you with the same length string what happens when he draws this shape where a pencil is kind of trapped inside of the boundaries of that string. Let's look again. He's going to do it 4 times. So he does that. This is kind of a flatter, and this is an ellipse. The shape that he gets is an ellipse, flatter ellipse. He's showing that the length of the string has a relationship to this long line here. We'll talk about that. And he brought those 2 points in together. They're called focal points. And he's drawing yet another ellipse. Let's get rid of that. And when he brings them on top of each other, what do you think we're going to get? Hopefully you see it, we get a beautiful circle. And so in a way, an ellipse is a type of a circle. Let's talk about it in more detail. So if I were able to see you in a live class, I would have done something like what he did. Probably not nearly, not even probably, definitely not nearly as neat. But let's go ahead and get started talking about what this ellipse is. So it is like a squash circle, and it has a particular quality that it's not just an oblong, any old oblong that you draw. It has to, or it is developed out of a certain place. So one of the things that we need to recognize is that an ellipse has two axes, and I'm going to kind of jump around and we'll get back. And one is called the major axis, and the other is called the minor axis. Major axis and minor axis. The major axis is kind of what you think. It would be the longest axis, and it's also the axis that contains those two very special points, those focal points that we'll talk about. So the major axis contains the focal points, and the orientation of this, by the way, could also be up and down, where the focal points are vertical as opposed to horizontal. And so that's something we need to keep in mind. So the major axis is this guy, and the minor axis would be the shorter axis, the axis or the symmetrical line that cuts through the ellipse that does not pass through the focal points. The center is exactly what you think it is. It's that point right there. And it's literally the center. It's the intersection of the two axes, if you will. And finally, we call this, I like calling these focal points because I always call it foci, foci, and I mess up the pronunciation all the time. So here I am, I'm going to turn to YouTube, right? Because why not? And figure out how to pronounce it. And so when I do that, I get, here I am trying to pronounce this. Let's hear what they say. Listen closely.
Foci or foci, American foci or foci.
Okay, there's just way too many pronunciations right there. And so maybe I should have you vote on the way you want me to say it. But I'm going to call them focal points and maybe foci or foci from time to time. I don't know. I always say it wrong. Anyway, so those are these 2 points here. And these 2 points are really, really important. Okay? These 2 points are really, really important because its location, the focal points, give us the shape of, and you saw that in the video, it gives us kind of the shape of our ellipse. It gives us the idea of what our ellipse looks like. So you're probably wondering, why are we studying this thing anyway? Well, what scientists have found is that ellipses are important to the study of our solar system because the fascination with the sky has caused people to wonder, observe, and make conjectures about planets since the beginning of history. Since the early 1600s, the orbits of planets have been known to be ellipses with the sun at a focus. Isn't that kind of cool? So instead of the sun being the center necessarily, it's at a focus, and I'm not sure why or how, but that's kind of an interesting observation to make. The sun is at one of the foci focuses, and you've got planets who have an elliptical orbit. And so that's one of the reasons why we study it. It's kind of beautiful when you see all this stuff come together. All right, so here we have just kind of an example where the major axis, so I'm just going to talk about this example and identify some things. The major axis would be this one here. The minor axis would be this one here. The focal points or the foci would be here. and the collection of all points that have a particular distance, right? Basically, the distance is going to be like this. The distance from every point on the ellipse is the sum of the distances from that point to each of the foci, right? So this point from here to here and here to here, and this point from here to here to here to here, and this point over here from here to here to here to here, right? All of these distances, the sum of these two distances, need to add up to the length. You guys get what I'm talking about? So I'm just going to throw another point. These two red lines should add up to these two orange lines, should add up to these two blue dotted lines, should add up to these two purple lines. You with me? So all of these, the sum of the distances from the foci, it has to be consistent in the entire ellipse. All right, let's get to some more good information. So let's go in a little bit deeper with this image, and it's going to be necessary for us to understand the next bits of information, so try to walk with me. So one of the things we are going to call the distance from here to here, A. And so A is really half the length. It's going to be half the length of this distance that we're talking about, the string that we saw in the picture, in the video rather. And then that string, if I were to push that point down and push out in this direction, the major axis has a length of, from 0 to A and from 0 to negative A, has a length of 2A. The minor axis is often, and I don't think we've defined it very nicely here, but the minor axis in this case is going to be referred to as B, right? The length is going to be B. So this would be 0B if we were centered at the origin, and 0 negative B, okay? And that's the minor axis, so the length is B. The distance from the center to the first focal point or foci is going to be C, as you see right here, okay? And you see that we get this right triangle situation. So let me write down what we've just learned. So the minor axis length is 2b, and the distance from the focal points is 2c. And look at the relationship here. They form a right triangle. So don't get this confused with the I know this is really confusing because I'm going to use the Pythagorean theorem, but it's going to look completely different. So the Pythagorean theorem in this case says that b squared plus c squared equals a squared. And that's just because the orientation and the letter usage is different. And I'm sorry that mathematics is confusing in this way, but this is what we got. So b squared plus c squared is equal to a squared. This is true only when dealing with an ellipse. B squared plus c squared is equal to a squared. And so that's how we're going to orient our problems. And so this is what we're going to use this to to study some problems. Now, as I told you before, sometimes our ellipse can be oriented in a couple of ways. So one way is that our ellipse is oriented horizontally like this, and sometimes our ellipse is oriented vertically. And what that means is that our major axis is vertical. It's going in that kind of way. And so the focal points are here, and everything that was true here is here, but now the X and Y have switched. And so it gets a little bit confusing. But again, if we're still working in this direction, if we're still thinking about it, the major axis length is still going to be considered A, except now it's going to be along the y-axis or parallel to the y-axis if we move it around. And the minor axis length is still going to be B, or 2B rather. And then the distance from the center of the ellipse to the edge, to the focal point is going to be C, okay? So this all stays the same, but what you're going to have to pay attention to is the numbering of the points, because we're not going to be able to like pick up the template and put it down exactly. You'll see as we do some problems. So here, this is a concept of how to organize what we're talking about. So one, the standard equation for an ellipse looks like this. Kind of weird, right? Not what you expected. It's going to be x squared over a squared, y squared over b squared, and these are a's and b's that we talked about, half the length of the major axis, half the length of the minor axis is equal to 1, or y squared over a squared plus x squared over b squared equals 1. Now let's talk about this real quick. If we look at it, when we have the equation, if the center, if it's, let me think, if it's in its horizontal, if the direction of the major axis is horizontal, that away, we have x taking the lead and x being over the length of half the length of the major axis squared. And if the orientation is this away, we've got the major axis, half of the major axis squared underneath the y term. This is really significant. This is really significant. I know it seems really crazy. So this video might take a little bit longer than usual, and we also might need to talk in person or via Zoom or something like that. And so this information is what we need to hold on to. The focal points here would be at a C0 or negative C0 given this standard equation. By the way, this is an equation that is centered at the origin. All ellipses aren't, and we'll talk about moving them around, but we need to get used to them kind of centered at the origin before we move further. And then this is a vertical one centered at the origin where the focal points or foci are located at 0, C and 0, negative C. All right, you see the difference between those? And then all the same things are 2A is the major axis length, and 2B is the minor axis length. All right, so let's look over here. Write an equation for the ellipse shown here. Okay, so we need so much information. First of all, let's consider what the orientation is. The orientation is vertical, so we're looking to have an equation in that form. So I'm going to write the standard form given that it's centered at the origin. So it's y squared over a squared plus x squared over b squared is equal to 1. All right, so this is the form that we're looking at, and of course this is one of the things we're going to memorize. And what we need to do is calculate the other information. Well, we might not have to. It looks like we can find it from our graph. So this is the minor axis. What's the length of the minor axis? 1, 2, 3, 4, 5. 5 times 2 is going to be 2b, so b is equal to 5. And the major axis, 1, 2, 3, 4, 5, 6. So A is equal to 6. Are you guys with me? I hope so. And so with that, our axis lets us know that we've got y squared over 36. That's the major axis going in the y direction. And x squared, that's x squared over 25, which is b squared. And literally that's it. That is how you get the equation of an ellipse from a picture. Yeah, picture from a graph. All right, so let's look at this next example. We have example 2. And example 2 reads, write an equation given the lengths of the axis. In an ellipse, sound or light coming from one focus is reflected to the other focus. In a whispering gallery, a person can hear another person whisper from across the room if the two people are standing at the foci. The Whispering Gallery at the Museum of Science and Industry in Chicago has an elliptical cross-section that is 13 feet 6 inches by 47 feet 4 inches. Write an equation to model this ellipse. Assume that the center is at the origin and the major axis is horizontal. So I'm going to draw what I have gotten from the information here. And after trying to draw this and talk to you in like the few minutes we have left, I'm just not going to be able to do it in a 15-minute chunk. So I'm going to have to go back and give you guys a new video. We're going to leave this here. So this is like a very interesting appetizer to the next video. We'll pick up this and more examples. I'll see you soon. Take care.